Dear friends, in mathematics, we evenly listen the term derivative of a function. In simple way, what is this? In mathematics, the derivative is a way to show the rate of change, that is, the amount by which a function is changing at one given point. It is the slope of the tangent line at a given point on the graph of this function. Let us consider that y is equal to fx be this function. Okay, this is a continuous function. Then the value of y depends upon the value of x. For this, x is an independent variable and y is the dependent variable. We use the word increment to denote a small change, that is increase or decrease in the value of x and y respectively. Let us consider that delta y be the increment in y corresponding to the increment delta x in x. Then friend, y is equal to fx be your curve. Now after some increment, say delta y, so y plus delta y is equal to f of x plus delta x. Okay, now we shall subtract the first one from the second one. So y plus delta y minus y is equal to f of x plus delta x minus fx. Okay, so that we are getting y is cancelled here. We are getting delta y is equal to f of x plus delta x minus fx. Okay, dividing both sides by delta x, so that we are getting delta y delta x is equal to f of x plus delta x minus fx divided by delta x. Okay, now friends, if we take the limit when delta x is tending to 0, so that we are getting limit delta x tending to 0, delta y delta x is equal to limit delta x tends to 0, f of x plus delta x minus fx upon delta x. Okay, now friends, the limit, if it exists finitely, is called the derivative or differential coefficient of y is equal to fx. Okay, with respect to x. Here this is x and it is denoted by dy dx. Okay, we can write this limit delta x tends to 0 of delta y delta x as dy dx. So we shall write it again here. Dy dx is equal to limit delta x tends to 0, delta y delta x. This is equal to limit delta x tends to 0, f of x plus delta x minus fx upon delta x. So friends, the value of dy dx, that means you can write it as also in this way, f dash x. Okay, f dash x obtained by putting x is equal to a is called derivative of fx at x is equal to a. That means if I substitute this x by a, that means f dash a, then it will be limit delta x tends to 0, f of a plus delta x minus f of a divided by delta x. Delta x is the small increment in a. Okay, so if f dash a exists, we say that fx is differentiable at x is equal to a. Okay, if f dash x exists for every value of x in the domain of the function, we say that fx is differentiable. Now we shall see the geometrical significance of the derivative. Consider that this is y is equal to fx with the curve. Let us consider that P be a point on this curve and whose coordinate is a comma f of a. What is a? A is a point on the domain of this function. So this is actually the point a comma 0. Okay, so another way we consider that q be a neighboring point on this curve of the point P. and the coordinates of q be a plus h comma f of a plus h. Okay, this is the neighboring point of p, and if we join p and q, we shall have a chord here, and this will make some angle with the positive direction of x-axis. So this is theta. Okay, so what is the slope of the chord PQ? The slope of the chord PQ is equal to, we know this one, this is y2 minus y1 divided by x2 minus x1. This is the rule. That means f of a plus h minus f of a plus h minus f of a upon x2 minus x1. x2 is here a plus h, so a plus h minus a. Now cancel a. Okay, we are getting here f of a plus h minus f of a upon h. Friends, let the point q move on the curve such that q is tending to p. Okay, q is tending to p. So when q is tending to p, then this chord qp will merge on the tangent at the point p. Say this is the tangent. Okay, try to understand what am I telling here. Suppose the point q is tending to the point p. Okay, it is coming here closer and closer to p. Then the chord, this chord pq will merge on the tangent line, at the point p. Okay, that means theta is tending to psi, another angle. Okay, so friends, when q is tending to p, then obviously this increment in x is also will tend to 0. That means then h is tending to 0. Is it? Do you follow this one? Again I repeat, q is tending to p. The coordinate of q and p are different. The coordinates of q are a plus h comma f of a plus h, and the coordinates of p are a comma fa. Now when q, that is when the point q is tending to p, then the increment in a, that is h, is tending to 0. So this is actually written here as q comes closer and closer to p along the curve, the chord qp approaches to the tangent at p. Okay, this happens when only h is tending to 0. So friends, limit h tends to 0, f of a plus h minus f of a upon h is equal to limit q tends to p, slope of chord PQ. Okay, that means what is this? Limit h tends to 0, f of a plus h minus fa upon h. What is this? This is the actually f dash x at the point x is equal to a. So we can write this as f dash a. This is equal to the slope of the tangent at p, at the point p. Hence the derivative of fx at x is equal to a is the slope of the tangent to the curve y is equal to fx at the point a comma fa, at the point p, that means the coordinates a comma fa. Okay friends, finally I write dy dx at x is equal to a is equal to limit h tends to 0, f of a plus h minus f of a upon h. This is known as the first principle of differentiation. Using these concepts, we shall find the differential coefficients of many more functions. So friends, the process of finding the derivative is known as the differentiation. So friends, please see the complete video once more. Your doubts will be cleared definitely. Thank you. Have a nice day.